January 15th, 1919, it's just after noon in Boston's crowded North End neighborhood, and suddenly, a deep rumble vibrates through the brick warehouses along Commercial Street. I mean, it sounds like a heavy freight train or distant artillery. Then this sharp series of metallic clangs just echoes through the freezing winter air. And seconds later, a dark, shining wave of thick syrup literally bursts outward, towering 25 feet high, surging through those narrow streets at an absolutely unbelievable 35 miles per hour.
2.3 million. That is the exact volume, in gallons, of munitions-grade molasses sitting inside this single, massive 50-foot tall, 90-foot wide storage tank, right on the waterfront. It was owned by the Purity Distilling Company. Now, you might be thinking of the sweet stuff you use for baking, but no, this wasn't for cookies. Back in 1919, this thick, brown syrup distilled from sugarcane was actually a vital feedstock for making industrial alcohol, which was heavily used in munitions manufacturing.
The people there didn't just see a flood coming at them. They heard a catastrophic structural failure happening in real time. It must have been absolutely terrifying. Witnesses reported a sharp series of metallic clangs, as if hundreds of steel rivets, just groaning under this immense pressure, were being torn loose all at once. The tank wasn't just leaking, it was basically unzipping. It burst wide open right along its base, dumping all 2.3 million gallons in one devastating instant.
The sheer kinetic energy of this sticky tsunami was, well, practically apocalyptic. As this wave swept through the brick canyons of the North End, it tore buildings completely off their foundations. It smashed the elevated railway tracks right above the street. The molasses was so dense it literally snapped the heavy iron legs off fire engines and lifted fully grown horses clean off the cobblestones. And because it was January, the freezing air rapidly cooled that waist-deep molasses, so it turned from a rushing river into something with the exact consistency of cold tar, trapping everyone and everything it touched.
The human toll was just devastating. 21 people died, and around 150 were severely injured. Many of them were just kids playing in the street on their lunch break or workers heading home for a hot meal. The rescue effort was an absolute nightmare. Cadets and sailors from the nearby USS Nantucket, along with local police and firefighters, had to wade into this freezing, sticky wreckage for hours. The molasses was so incredibly thick that some victims pulled from the rubble were completely unidentifiable, even to their own families for days.
So how does a nightmare like this actually happen? Well, we have to look back 4 years to 1915 when this tank was built. They were in a frantic rush to meet that wartime demand for industrial alcohol I mentioned earlier. And the gap between what the design required and what was actually built is staggering. They used steel that was way thinner than the specs called for. Its manganese content was way too low, making it incredibly brittle in the cold. And get this, they filled it to capacity without a single hydrostatic test, meaning they never even filled it with water first to check for leaks. But here's the kicker. There wasn't a single engineer on site during construction. The entire project was overseen by the company's treasurer, a guy with exactly 0 engineering qualifications.
Now you'd think maybe they just didn't know it was failing, right? Wrong. The company absolutely knew there was a problem. From day one, that tank groaned. It leaked from its rivets so badly that neighborhood kids would actually walk up, scrape the leaky molasses off the steel walls with their fingers, and eat it like candy. Mothers even sent their kids out with pails to collect the drips for baking. But instead of reinforcing it, or draining it to inspect the steel, the company came up with a wildly irresponsible fix. They just painted the entire tank brown. Yep, it was the perfect camouflage. In one stroke, those massive streaks of leaking syrup became completely invisible.
The actual science behind the collapse really came down to a catastrophic cocktail. On January 14th, the day before the disaster, a fresh shipment of 800,000 gallons of warm molasses arrived from the Caribbean and was pumped right into the tank. So think about it. You've got the freezing January air making that substandard steel even more brittle. Then you introduce all this warm liquid, causing thermal expansion inside a cold tank. And finally, that warmth kicks off a fermentation process in the molasses itself, rapidly producing carbon dioxide gas and drastically spiking the internal pressure. It was literally a ticking bomb. Those underdesigned rivet seams gave way at one weak point near the base, and the pressure blew the tank apart like a tin can, hurling massive fragments of steel outward like artillery shells.
In the aftermath, the surviving residents brought a massive class action lawsuit against the United States Industrial Alcohol Company. And you might expect some kind of settlement, but instead the corporation launched this totally absurd legal defense. They stood up in court and in the press, and with a straight face argued that the tank had been blown apart by Italian anarchists. Seriously. They tried to scapegoat a political movement that was active with bombings at the time, completely sidestepping the fact that their treasurer built a groaning, untested tank out of cheap steel and just painted over the leaks.
But this tragedy actually built the foundation for every single building we step into today. The legal battle dragged on for 6 grueling years, involving over 1,000 witnesses. Finally, in 1925, court-appointed auditor Hugh W. Ogden delivered a judgment that effectively birthed modern American structural engineering codes. He found the company entirely at fault. Because of this exact disaster, Massachusetts mandated that actual licensed civil engineers must oversee, sign, and stamp construction plans. Hydrostatic testing became a strict legal requirement. Structural engineering became a highly regulated practice, and these laws, they quickly spread across the entire United States.
The cleanup took months. They actually had to pump salt water straight from Boston Harbor just to wash the streets, and reportedly, the harbor water ran brown until the summer. Those cobblestones stayed stained for years. Now, modern science tells us that weather and microbes would have broken down any physical residue decades ago. But if you walk through the North End today, there's this lingering tradition. Locals swear that on a really hot summer afternoon, when the asphalt softens and the wind blows just right across the waterfront, the air still carries, faintly but unmistakably, the sweet smell of molasses. It really begs the question, how many of our modern safety codes are written in the invisible ink of past disasters?